Hello, welcome back. My name is Chris Barker. I'm a program manager on the Windows Partner App Experience team.
And my name is Daniel Jacobson. I'm a program manager on the Visual Studio team, primarily focused on tools for Windows developers.
Today we want to share with you how you can take your existing WinForms and WPF apps forwards using the Universal Windows Platform, Visual Studio, and .NET Standard 2.0. Now we're going to have questions coming in throughout. Please keep them coming in. We'll take any of those questions as we can, but we'll also save some time at the end to help answer some of those questions. Also, if we don't get to some of your questions, feel free to tweet us. We've got our Twitter handles here on the front page, so we'll get back to those questions as quickly as we can after the session as well. So with that, let's start by talking about the Universal Windows Platform and giving you a refresher on some of the benefits really in starting to target the Universal Windows Platform for your apps. So the first thing is the modern experiences that Universal Windows apps can bring for your application. So you may want to get the adaptive user experience from your apps. It may be tapping into the multiple natural user input modalities that the user experience can achieve through UWP apps. But then there's additional benefits as well, such as being able to reach new audiences. So by having your app target the Universal Windows Platform, your app can start to run on those different devices such as a HoloLens, a Surface Hub, all the different Surface desktop laptops today as well. And then additionally, you can start to increase engagement inside of your apps. So this may be through simple toast notifications into your app through push notifications, and also live tiles and a myriad of other ways to integrate into the shell. Now, the often overlooked example as well of targeting the Universal Windows Platform, the big benefit there is the benefits around servicing and packaging of your app. So not only can you deploy it to the store or the store for business, but actually, no matter how you deploy your app, you also get the servicing benefits. So your app can upgrade seamlessly in the background. So if you're starting from a WinForms or WPF app today, or any kind of really Win32 based app, we want to think about how we enable you to continue those investments going forwards. And so everything we show to you today is going to be talking around how you can continue development of those apps, but also start to see some of the benefits of targeting your app towards the UWP platform. So with that in mind, what's the first step to start to light up some of these modern experiences? Well, you can take your Win32 app, your WPF app, or your WinForms app today, and simply start calling into those new Windows 10 APIs when they're available. And we'll show some examples of this as we move on to demos a little later. But this can be using those toast notifications. It can be using the Windows Hello for additional security checks inside of your app, and we'll show some of those examples working. Now, I mentioned some of the benefits of packaging your app into a package, an AppX package. And a simple way to do that is by using the desktop bridge. This enables you to wrap your existing WinForms WPF app up inside an AppX package and get the benefits around servicing and deployment. The Universal Windows Platform generally is going to enable you to target new audiences, and you can do that through all of these new devices that I mentioned previously. And then if you want to go beyond Windows, we also have a development story here as well through Xamarin Forms. So Xamarin Forms will enable you to use your .NET skills and start to move beyond Windows and onto target platforms such as iOS and Android, all at the same time being able to keep that same common code base and reuse wherever possible. So we're going to focus our time today on taking those WinForms and WPF apps, taking as much code as possible and moving them to a Universal Windows Platform app. And we will show this in a working demo. But before we get to that, let's talk about .NET. This is .NET Conf after all. So why should you care and consider continuing to invest in .NET? Well, .NET alongside Visual Studio and Azure in the cloud as well enables you to have that full end-to-end story. So you can develop client-side apps, server-side apps, and you also get additional tools there to support that full end-to-end through DevOps, testing, debugging, etc. And this is going to enable you to maximize productivity, and it's also going to enable you to reach that enterprise scale. .NET, along with Visual Studio, have been around in the enterprise for a long period of time now and continue to be ever popular. And we're moving .NET forwards as well to enable you to target those new modern experiences with the runtime and with the platform too. So there's been a little bit of confusion in the past when we start to talk about .NET and running against various app models. So when we talk about .NET today, and when maybe in respect to your WinForms WPF apps, we're really talking about the .NET framework that gets deployed as part of the operating system. Now, you may also have heard .NET mentioned in the same breaths as Xamarin and UWP. Well, for UWP, for example, that uses .NET Core, which is a different app model, but it enables you to use those same skills as you move across from one app model to another. And then Xamarin Forms as well enables you to, and Xamarin Platform enables you to take the .NET skills and move across onto iOS and Android using the same skills. But what we've been lacking today is binary compatibility. If you develop some IP and a set of logic sitting inside of a class library, you've not been able to easily move that across because there's been different underpinning base class libraries there. .NET Standard enables us to target that particular scenario and reuse your skills and get the binary compatibility as you move across each of these app models. So let's talk about interoperability. So there's 3 example app models across the top here. You can see a .NET Framework app, a .NET Core app, which may be UWP, it may be ASP.NET Core, and also a Xamarin app as well. These can now all target that exact same .NET Standard library. And we also wanted to keep in mind that you want some compatibility with existing libraries that you've built for cross-platform reusability. And so if you're targeting an earlier version of .NET Standard library today, you can also reference that from a .NET Standard 2 library. Now, we also had a solution in this space previously, which was portable class libraries. .NET Standard is going to supersede portable class libraries. There were some constraints previously around portable class libraries in that the more target platforms you selected, the smaller surface of APIs that you had access to. And you would end up with a resultant profile that really didn't mean a lot to people. So by having the versioning associated with .NET Standard, it makes it much clearer now around which APIs you're going to have available to you. Now, we didn't want to forget about existing libraries that are written and targeting .NET Framework, so we're also providing a compatibility layer in there as well to enable you to take your .NET Standard 2 library and reference some .NET Framework libraries, and we'll come into that in some more detail as well. So let's look at the big 2 investments that we've made for .NET Standard 2, and it's in relation to my previous point, which is when we started to think about designing .NET Standard 2, we went into the NuGet store and took a look at all the different libraries out there today and the different app models or versions, flavors of the framework that were being targeted. And it was a fact that the majority of those libraries were targeting the .NET Framework. So going forward and having this story of reuse, we wanted to make sure that a class library built against .NET Standard 2 would be able to maximize reuse and reference the majority of those .NET Framework class libraries. And today, with .NET Standard 2, we're able to light up 70% of the libraries in NuGet in terms of support and what we can reference from a .NET Standard 2 library. Now, this was enabled by when we did that initial pass-through and started to look at the different APIs that were being used, we figured out what the biggest subset was across all the different app models. And as a result, with .NET Standard 2, we've lit up 20,000 new APIs over .NET Standard 1.6, which is a massive advancement there. So the different APIs, 20,000 is quite a lot to comprehend. So you can see here some of the big buckets that these APIs fall into. So you've got some core APIs such as reflection APIs, up through serialization, XML, and then an area we're going to spend a fair bit of time on today around data. So you'll see some of these familiar classes that you may have been using in WinForms and WPF up till now, the data set, the data table, and SQL client as well. So we'll show you how you can use those in UWP and beyond. So we're going to start to switch over now to show you some demos and get stuck into Visual Studio and do some coding. But before we do that, let's just quickly level set on the scenario we're going to walk through. So we're going to take a canonical Northwind application. This is a WinForms application. It's layered into a business logic layer, a data access layer, and it's calling through to a SQL Server Express instance in this case. What we're going to do is identify the different areas of the app which are prime candidates for moving to .NET Standard, and we can show how to light those up. And then we're going to start to add on the Universal Windows Platform app and show how you can just reuse that exact same code from a Universal app. And then we're going to show how you can co-evolve these apps. Remember, everything we show today is in mind of reusing your existing investments. So we want to show how you can move both along at the same time and then where it makes sense, where you're tapping into this brand new audience for your UWP apps, you can start to light up specific features for UWP wherever it makes sense for your scenario. So with that, I'm going to jump into Visual Studio and give you a demo and a walkthrough here on some of the considerations and some of the thought process you should be going through as you start to light this up. So on the right-hand side here in Visual Studio, you can see that I've got a WinForms app. This is purely my UI. I've got a business logic layer that then calls into my data access layer. And inside of my data access layer here, it's really just a data set. In the business logic layer, this is fairly light here for this demo, but it's enabling me to call functions such as get customers. That will return a data table being part of .NET Standard 2.0, and then I just feed that data back into my UI. So if I run the app up and show you what we have here, it's a pretty standard app that you may have seen previously, but it's 3 data grids on a form. It's a customers data grid, a orders data grid, and an order details data grid. And this has given me that kind of master details view, so I can start to select through here, and you can see the other data grids reflect the changes I'm making. I then at the top here have a menu, and in here I can hit edit mode, and that then lights up this option on the menu to go create a new order. And in here I've got a new order form where I can go select the customers. So again, these are all being pulled from the SQL Server database. The products I can go select in here. I can say how many units I want for this new order I'm creating, and then hit submit order. So let's just close that down for now and come back to our project structure. So we have a WinForms app, that's the UI, we have the business logic layer, we have the data access layer. What we're going to take today is the business logic layer and the data access layer and show how easy it is to take those over into a .NET Standard library, and then we'll start to move on through to lighting this up on the UWP app as well. So what is that thought process that you should go through? So you need to first of all think about what your project dependencies look like. Are you simply depending on other projects that you own? Are you depending on third-party projects? That's the kind of the thought process you need to go through, and then start to understand the APIs that they call and figure out if .NET Standard provides support for those APIs. So if you go into the GitHub repository that we have for .NET Standard, you'll see that we have this pretty interesting table here that shows you all the different versions of .NET Standard across the top. And we're of course concentrating on .NET Standard 2 today. And you can see on the left-hand side we have the different app models and which versions of those app models support .NET Standard 2. So for .NET Framework, which we're using from the WinForms app in this case, requires that we target 4.61 of the .NET Framework. In other words, if we're not using 4.61, we need to make sure that we upgrade to target that version, which should, for the most part, be fairly seamless. And then if we're using or want to use the Universal Windows platform, we need to be targeting vNext of the SDK. vNext in this case means the full Creators Update that will be available later this year. So you'll need the full Creators Update version of the OS and the SDK in this case. So that will start to give you an initial understanding depending on which projects and app models you want to light up. And then as you click through in GitHub here, you'll start to see this screen, which is a view of all of those 20,000 APIs, which is fairly comprehensive, fairly daunting. I'm not going to spend a lot of time on this today, but you can start to see if your app depends on a certain API, and you can do a search through here, obviously, to see if that is available. Now, that's quite cumbersome in going through that, so we actually make it even easier for you to do that initial analysis, and we provide a tool called the .NET Portability Analyzer. Now, the .NET Portability Analyzer is available as an extension through the Extensions Gallery in Visual Studio, but we also provide it as a command line tool that you can run against your different assemblies. So what I want to show now is how we can run that command line against our business logic layer assembly and our data access layer assembly, and just take a look at some of the input that gives you back. So here I'm going to switch over to my command prompt, and if I just take a look at the folder in here, you can see that we have a couple of interesting files. One is the BLL DLL, and one is the data access layer DLL. So API port is the name of the tool that we have in here. And so into there, we're going to ask it to analyze the data access layer in this case. It's currently targeting .NET Framework 4.5, and we want to get a delta of the supported APIs for .NET Standard version 2.0. And then we're asking it at the end here to give us a HTML report where we can go and look at the work that we need to go do to bring it across to support .NET Standard 2.0. So if I run that through here, it goes and does some analysis, and then it gives us a HTML file out the end. So if I go back into my browser here, you can see I've run this ahead of time. And for my business logic layer, the project I showed, which has that very thin layer right now of method calls, you can see actually, fortunately, we have zero work to do because the 100% of the APIs that we have in the .NET Framework 4.5 version of the class library are available in .NET Standard 2. So that's going to mean there's very light work for us to light this up for .NET Standard 2. Now, if I go over to my data access layer, it's not a terrible story here, but we have 93.67% of APIs that are supported for .NET Standard 2. So we have a little bit of work to do, but it's not too substantial. So if I just zoom this out, you'll get a better view here of the different APIs that we need to go and think about porting over. So this is a little bit small on the screen, but if I scroll through here, there's basically 3 categories of APIs or code that I need to go and port across. The first is the connection string to my database. So the way that a WinForms app does this is it stores it inside a properties file inside of a settings class. And so there is no concept in the .NET Standard 2 implementation of the settings base class. So we need to polyfill that in some way when we move it across to a .NET Standard 2 library. The other category in here that's missing is a SQL client implementation. Well, actually, the implementation is provided to us through a .NET Standard library that's available in the NuGet store. So I'll go show how we can download that and fill that gap. And then finally, just at the bottom here, is we don't have access to this type table base, and that's for strongly typed data sets where your data row will inherit from a type table base. And so we need to provide an implementation of that class. Now that's going to be available also on NuGet in the coming days and weeks, but I have a locally built version for the purposes of the demo today, which I took from the .NET Core SDK. So you can absolutely go and build this yourself today as well. So with that, I'm going to switch back over to Visual Studio. And we're going to start to port our code over here. So I'm going to first of all go to my WinForms app, and the first thing you'll remember is that we need to make sure that we're targeting .NET Framework 4.6.1. So I'm going to update my projects in here to do just that. I'm going to do that for my business logic layer. And I'm going to do it for my data access layer as well. And you'll want to do this in maybe different steps depending on how quickly you want to move through targeting .NET Standard 2. So maybe this is the first step. You make sure that everything's working correctly and is compatible. In this case, I can tell you it will be. And then the next step I want to go do is create the .NET Standard implementations of each of the logic layer and the data access layer. So here I go to create a new project, and I go to create a new .NET Standard project. And in here I'm going to go call this northwind.standard.bll. And I'm going to do the same for the data access layer as well. Now, by default, when it goes and creates these new .NET Standard projects, it's going to be targeting .NET Standard 2.0, which is exactly what we want in this case. So we'll go create that. We have some placeholder classes in here, which we're just going to remove. And then for my business logic layer, all I need to do in here is add an existing item and point to those exact same classes that we have in our .NET project. So I'm going to take those in here and add them in. Now, if you had multiple UI apps, depending on these, then maybe you would want to do some file linking here, so the older apps can still target the existing files and existing project, but we're not going to do that here. We're taking a full copy. And then I want to do that same thing for here for my data access layer, and I'm taking those dataset files in this case and bringing those across into the new project. I then need to add a reference in my business logic layer to my new data access layer. And then when I go to build the data access layer, we're going to see those errors that were flagged by the API port tool. So again, this can look somewhat daunting the first time you see it, but out of all these errors, there's really only 3 categories of issues that we need to go solve here. We can see that SQL client is a fairly big category in there. So all we need to do here is go into Manage NuGet Packages, and we'll search for the system.data SQL client package, and we'll install that into here. So we'll just give that a moment to download and install. And that's going to remove a big set of those issues that we just saw. And if I build again now, we have a few less errors in here. So the next one we have is the type table base error that again we saw in the report. And for that, we're going to be able to add a reference to the NuGet package. It's not available just yet, as I mentioned. So for now, I just have a local assembly that I'm going to go add a reference to. So system.data.datasetExtensions is where this lives today. I'll add that in here. I'm also going to add it into my business logic layer because there's type dependencies there as they get pulled through. And the other interesting portion of this as well is that for my WinForms app, I don't want to be using the BCL version of that assembly. I want to be also using the .NET Standard version. So I'm going to add a reference to that in there as well. So back to my data access layer. If I build this now, I'm going to have a single category of error left, and that's around the properties not existing in the data access layer. Remember, these properties are the connection string and the settings class that I mentioned previously. So in here, I'm just going to add a helpers folder so we can keep it nice and separate from the polyfill work that we've had to do from what we got for free. And then in here, I'm going to go create a new settings class. And just so you're not watching me type, I've actually gone and pulled this ahead of time. So I'm going to delete that in there and just drag across my code snippet here. But you can see it's a very lightweight class that I've had to bring across here. It's a settings class with a nested default class, and then it just has a single Northwind connection string in here, which is pointing to my local SQL Server Express database. So I'm going to build that. And you can see it now succeeds. And my business logic layer will also succeed. So all that's left to do now is go back to my WinForms app and remove the existing .NET Framework implementations of these class libraries and add a new reference to the .NET Standard versions. And we can rerun this up. And we should now be in a good place to go on and do that further extension work to bring our app to new audiences and bring new modern experiences to our app, all because we can get the reuse of code through .NET Standard and through the business logic layer, data access layer to the SQL Server database in here. So you can see this is all working just the same. So with that, I'm going to switch over back to the slides here, and I'm going to hand over to Daniel to talk some more about some of the more specific .NET and UWP advantages that we get.
So I'm assuming many of you attending this specific presentation are coming from WinForms or WPF, traditional .NET Win32 desktop development. We've made some enhancements with the Universal Windows platform that will have a little bit of an impact on the way you think about your application development. So I wanted to share those with you right now. First and foremost, we've created a new technology called .NET Native that we essentially enforce for all public UWP applications submitted to the Windows Store. What .NET Native does is it essentially takes your intermediate language binaries from the .NET compiler and compiles them into native code. This means you have no just-in-time compilation at runtime and a much leaner runtime for lightning-fast startup. We've also observed about a 40% lower memory usage for apps compiled with .NET Native. And one nuance to this technology is that the store does the compilation for you. Now, .NET Native with Universal Windows Platform is especially important when you consider the context of the Universal Windows Platform. As Chris mentioned previously, one of the unique advantages of UWP is that it targets pretty much any Windows device family, from the most powerful desktop PCs to the $30 IoT Raspberry Pi dev kits that you buy that have pretty much hardly any processing power. So by enforcing .NET Native, all these lightning-fast apps just make a more performant platform for everyone. The store compilation is interesting because it will actually affect your developer workflow. So I want to get into that now. And the reason we do the cloud compilation is just in case we were to ever encounter any sort of bug or issue with the compiler that may impact developers, we don't want to enforce or require every single developer to resubmit their application package. So we can actually recompile apps for developers, and everything should just work. So when considering Universal Windows Platform development, you're obviously going to start by creating your new .NET UWP project in Visual Studio. And for the most part, your day-to-day work is going to be pretty much the same as what you would expect with WinForms or WPF development. Personally, my favorite way to build apps is to just debug against x86 on my local machine, as that's just the fastest development cycle for myself. Local machine is my fastest computer. When I want to test on my remote devices, I do so as I'm getting closer to a release build. What's really important with .NET Native, though, is that you test release builds more frequently, because by default, Visual Studio will invoke a local .NET Native compilation on your project in a release configuration of your project. So if you want to make sure that everything works as expected post .NET Native compilation without having to rework some of your code, if you do this once or twice a day, you won't have to go back and figure out exactly where the errors went wrong. In addition, because UWP supports so many different target device families, we highly recommend you test on all different target device families before publishing your app to the store or distributing for any sort of consumption. Finally, because the store does the .NET Native compilation, it's especially important that you submit the right artifacts to the store. If you use the Visual Studio tooling to create packages for store submission, we'll generate a file that has an extension of appxupload, which is the package that you're supposed to upload. This contains all of the necessary store metadata for store submission, as well as the intermediate language binaries that the store needs to recompile your app using .NET Native. And then it'll hold on to those artifacts just in case recompilation ever needs to happen. In addition, we've changed the way .NET is delivered with the Universal Windows Platform. Chris hinted at this earlier when he was mentioning the difference between the desktop .NET Framework and .NET Core. And UWP is built on top of .NET Core. So the way .NET is delivered with Universal Windows Platform is actually part of your application as a set of NuGet package references. And we use in Visual Studio 2017 the new NuGet package reference model. So everything is embedded in the project and has direct MS Build integration and all sorts of advantages that we'll get into in just a moment. But the primary benefit I want to highlight here is that you're no longer tied to your customer's environments. So all you need is Windows 10 with your target platform min version, and you don't need to worry about what version of the .NET framework they have installed on their machine. So you can iterate much more quickly with advances in .NET, which is especially important given the upcoming .NET Standard 2.0 implementation in the Fall Creators Update. So NuGet package reference gives you some other advantages, such as direct MS Build integration, which allows you to essentially provide UWP-specific target framework monikers. This is for those .NET NuGet package library authors out there. But now you can author your UWP libraries specifying the target platform min version requirement of your libraries. Now, say you wanted to build a UWP-specific class library that takes advantage of some UWP-specific APIs, and you need a min version requirement, you can do that with specifying the right framework moniker. What's also really cool with the package reference model is we now support platform multi-targeting for NuGet packages. And what that means is you can create a single NuGet package with multiple implementations of the same code, same library, for different platforms. And what this means for UWP is that we essentially have a single NuGet package that contains the implementation with .NET Standard 2.0 for Fall Creators Update projects, as well as the .NET Standard 1.4 implementation for any sort of project that is before the Fall Creators Update. So as a developer, this means that you only need to worry about one single .NET Core package reference, and that'll work across all of the different Windows versions. So we have a question from the audience. Could you guys explain what is store compilation, please? So what that means is that the store actually ingests a version of the .NET Native compiler that we also ship in Visual Studio. And when you submit your package to the store, you ship it in an intermediate state. So you don't ship the full .NET Native version of the package. When that gets uploaded to the store then invokes the same exact .NET Native compiler that you would on your local machine on the app. And the version of the .NET Native compiler is embedded in the package manifest so that they use the right version in the cloud. The only reason they do this is in case we do identify any sort of gap or hole in the compiler, we can upload a new version of the compiler to the store that is essentially just a minor version update that should have no breaking changes in the way your app behaves, but the store can recompile your app without you having to resubmit the package. Rick, I hope that answers your question. If not, please shoot us another one. So one thing that I really want to call out that's especially important, and I'll show a demo of when this goes wrong, is that .NET Standard 2.0 for Universal Windows Platform development requires the Windows Fall Creators Update. For those of you who are familiar with UWP development, you're aware that you can do platform adaptive coding against WinRT APIs, but since these are just .NET APIs and not WinRT APIs, you actually need the implementation in order to execute the code. We have one more audience question, and then we'll get into the demo. Greg asks, can we get some context to the 40% memory reduction observation? Is that for an initial load or over app's lifetime? That's observed over the application's lifetime. So as you run more apps, you should see a much lower memory footprint of Universal Windows Platform applications. So let's return to where Chris has us set up to essentially build our UWP application on top of the artifacts from our Win32 development. So in the UWP folder, I'm going to go ahead and add a new project, which will be a UWP project under Windows Universal. And I'll just call it northwind.uwp. For now, I'm just going to select the defaults. So my minimum version is the Windows 10 November update, and my target version is the Fall Creators Update Preview, which is available if you're installing the Visual Studio previews or if you're a Windows Insider. The first thing that I'm going to want to do after I create this project is go ahead and add a reference to my .NET Standard 2 class libraries and make sure that the project builds. So let's go ahead and do just that. Whoops. I need to go to add reference. Standard. OK. And now let's just try to build the project. Now, for those of you who are following along closely, you'll probably recognize that this is actually not going to build. And that's because we set our minimum version to the November update rather than the Fall Creators update. So what you'll see down here, if you scroll down below, project Northwind standard.dll is not compatible with this version of UAP. Instead, it needs .NET Standard 2.0. So I can go ahead and fix this by observing the project properties of my UWP application and going ahead and updating the min version. Now note, I don't need to change any of my NuGet package references because both the .NET Standard 2.0 implementation and the previous .NET Standard implementation is in the same exact NuGet package. So now if I go ahead and try to build this project, it should succeed. And we're getting a couple of questions. So as this builds, I'll go ahead and answer them. Do we still need runtime directives with UWP.NET Standard 2.0 by SIA? So runtime directives were used for .NET Native. We've been constantly trying to improve the .NET Native compiler to reduce user interaction whatsoever. You should need no runtime directives with UWP and .NET Standard 2.0. But if you do, go ahead and reach out to us at my Twitter handle, and I'll get you in touch with the right folks. Sean asks, what about source code security if Microsoft Store now has access? We don't look at any sort of your source code. We only have the Microsoft Intermediate Language binaries. We never actually take a look or inspect any of that. This is really just to make sure that the .NET Native compiler can fix any bugs that we may have, which so far has never happened. We don't expect it to happen, but it's a backup if we need it. What is the strategy and best way to update PCL libraries to .NET Standard 1.4 and 2.0? Scotty, that's a really good question. What I would personally recommend is go ahead and just copy over the classes from your existing PCL libraries to .NET Standard 2.0, or use the API port tool that Chris was showing earlier to essentially go between those two or multiple different platforms. So as you know, Portable Class Library essentially takes the intersection of libraries available in the targeted .NET platforms and makes those available to you. So by doing specific platform analysis, you could figure out what's going to work and what's not. Bitbonk, is there a comprehensive list of things I can't do with UWP compared to desktop apps due to the sandbox? I'm not aware of anything like that, but go ahead and send me a tweet. I think maybe we should get on to writing some documentation specifically geared.
So we do have some documentation in this area that will give you a flavor of that. But as Daniel said, if it doesn't, if you go to docs.microsoft.com and do a search there for Universal Windows Platform, or even hit dev.windows.com, it will direct you in the right direction for some of that. But if there's anything you can't find, feel free to hit us up on Twitter and we can give you some more details there.
And Kumar asks, there's a direct tool to convert WPF application to UWP. I'm not sure exactly what you mean by that. If you could rephrase the question, we'll be happy to get back to you.
I can jump in there.
Sure.
So I think what we have the closest today to what you're looking for is the desktop bridge. And so there's a desktop app converter tool that you can go get. And again, if you search on dev.windows.com or docs.microsoft.com, it should point you in the right direction there. It's not going to give you everything for free, but it is a tool that will move you some of the way along that journey there. Then you can end up with a Win32 portion of your app and then a UWP portion of your app, talk between the two using an app service, and that will start to move you on that path, on that journey. And
I'll pass it back to Chris as he essentially takes us the next step along the journey to support the exact same functionality in the Universal Windows Platform application using pretty much the same exact code behind.
Thank you, Daniel. So yeah, I'm going to use the app that Daniel just kindly created for me in here. So the Northwind UWP app. And so just to set this as the start project in here, I'm going to show that the work that we did earlier to bring the data access layer and the business logic layer to .NET Standard 2 can now be really easily reused here in our new project. So you'll see that he's already added in the references there to the two .NET Standard projects. I'm going to create a very, very simple UI here to be able to pull in that data through those channels. So I'm going to go into the XAML view in here. You can use the designer view, obviously, if that's more comfortable for you. But I will just drop into the XAML in here. I'm going to make this a relative panel. I'm going to give us a button in here to go create the request to the data. We'll say get data. We'll give us a click handler in here. Again, if you're more comfortable with a view model type pattern, you can do all your binding in here, obviously. I'm just going to do everything in code behind for now. And then in here, I'm going to go create a list view to go display our data. We'll just call this list view 1. And we'll just put this right below the button there for layout reasons. And then we're going to go set the item source for the data that will drive this list view in the code behind. Now, the data that comes back is going to come from our customer's data table. So in this case, we have a property on there called contact name. So just to make this render a little bit more friendly on the screen for us here, I'm going to just give a hint here as to the property it should use, and that's contact name. And then I'm going to go drop into my code behind here and find that button click handler. And then in here, I'm going to take that list view I just created, get the item source on here, and we're going to then call into our customer's business logic layer. And we'll just resolve the namespace reference there. And now we're calling into that exact same class library. So when I run this app up now, we'll get a button once it's done the building and the deployment in here. We're going to hit that, and then it's going to go call through all of those layers and into our SQL Server database that, by the way, for development purposes, is also running on this machine. So here we have our Get Data button. We hit Get Data. And there you go. So we now have all of that data from the SQL Server database coming through and being displayed in our list view. And I really want to just pause at this moment and underscore what a big deal this is. So all of those investments that you guys have been working with data sets, data tables, SQL Server connections directly from your app, from your UI for a good number of years now. This is now possible for a UWP app. And not only for a UWP app, but you can also start to share that exact same code for UWP, for Xamarin running on iOS and Android as well. And we have other sessions at .NET Conf that will show some further details there. But this is really a huge step forwards that UWP, .NET Standard 2.0, and Visual Studio are helping us enable. So this is a really basic vanilla app. I want to start to show some of the additional benefits that you're going to get from moving to UWP. And so I've got another app here that I created, another UWP app. We're just going to add the references into the .NET Standard library as we did previously. And we're going to start to wire up a bit more on the UI side in here. So I'll just run up the app just to show you what we have in here. But it's basically just an app with a button, which is what we saw previously. I do have a view model in here. That's going to come into play when I start to show you one of the data forms that I've gone and created ahead of time in a moment. But we're just going to try and get as close as possible in as little time as possible to that same scenario that we saw in WinForms. So here you can see I've added some icons in here for the splash screen and just kind of prettied this up a little bit. But all we have right now is this button doing not a lot. So back into my app and back into my code in here, I'm going to go to my main page. And I've only done a few little tweaks in here. So the first thing that we want to do, if you think back to the WinForms app that we had the menu at the top, and then we had 3 data grids below. So what I want to show here is how I can bring in each of those controls in the UWP world. And we have a great third-party control ecosystem here as well for UWP, and a strong open source community as well. So not only can you go pull the controls down for your particular apps, but you can also go see how they work behind the scenes as well. And 2 of those libraries I've chosen to use here today to light up this scenario are the Telerik controls, which are open source for UWP on GitHub. And also, so you can see I've referenced Telerik in here, Telerik UI for UWP. I've also referenced the UWP community toolkit that has a huge number of controls as well. And if you want to check that out some more, go to the store, download the sample app for it, and you can start to play around with all the different controls that it offers. But specifically in here, all I'm going to introduce is the menu control from the UWP Community Toolkit, and then the data grid controls from the Telerik library. So I'm going to replace this button that I created previously. Let's give ourselves a bit more room in here. I'm going to replace the button with a menu. And the menu, again, it's coming from the toolkit. All it's doing in here is it's saying I want to create a new menu. I've got a file item in here, and I've got an edit item, and then I've got a click handler behind each one of these to go and do the relevant logic. I then want to bring in my data grids. So 3 data grids again, a customers data grid, a orders data grid, and a order details data grid.
Oops.
Oop, wrong one.
Out the menu. Yep.
There we go. So in here, we have those 3 data grids, and we also we're binding these to the view model that I have sitting behind these. But you saw a moment ago, I went and pulled the customer's data table through the direct code call. You can absolutely do that in here, but I'm just using binding in this case. We have an orders data table, an orders detail table as well, and then we have a few extra properties on here to go generate the columns for us. So if I run this back up again now, we're not entirely there, but we're moving much closer to what we saw from the WinForms app. So we'll just give that a moment to go build and deploy and run up again here. And then in here, what you're going to see is the Telerik grid, customers grid at the top, orders, and then order details down in here. And we've just done the wiring in the background there to give us the master detail view and the selection behind each of those. And then what we also have at the top here is the menu control that we brought in from the UWP Community Toolkit. And that's got the edit mode toggle on there that we saw on the WinForms app. And we'll also wire that up in a moment to go create a new order. And you'll see in here, like the data grid off the bat is giving you a lot of functionality, such as grouping. So if I had a bunch of different customers with certain titles that I wanted to go filter by, I can go do some grouping in here, and it will go group those up for me. So back to the menu, if I go toggle edit mode in here, I just want to show you some of the pre-wiring I've done for the UI on the data form as well. These are just kind of simple intrinsic controls that I bring in, so a drop-down box, a text box, labels, those kind of things. And you can also see here I've brought in another Telerik control, which is the numeric up-down control here to give me a few more benefits over a standard text box. Another call out here as well is notice that maybe it's not so obvious, but each of these controls can support multiple input modalities again. So it may be the mouse and keyboard, it may be the touchpad, it may be my finger, it may be a pen. We provide support native through the controls for each of those different input modalities. So the next thing I want to show is how we can do this kind of co-evolution of both apps, so the UWP app and the WinForms app side by side. So in here, I just want to close this down, and rather than just having the simple toggle for edit permissions on and off, I want to start to light up Windows Hello. So Windows Hello enables us to introduce biometrics into our app to get that additional security around authentication, and that's exactly what I want to show now. So in my UWP app, I've created a service called User Consent Service. And if I go into here, this is just linking straight through to the WinForms flavor of that file. So if I go into here, you can see I've got services folder and that exact same file in here, so I can make changes to both at the same time. And then I'm going to uncomment some code I have in here already to go enable that. And I'll just give you a quick run through here, but we're checking that the Windows 10 API is available first of all on this machine, on this device. So we're checking that the user consent verifier is available. And then we're checking that it's actually available on this particular machine. In other words, it's enabled for this particular user. And then if it is, we're going to request verification. We can pass in a particular string. You're about to enter edit mode. It will check who I am through the biometrics that are available, and then it will grant us access. Now, for UWP, you would just add this code in there. For the WinForms portion of that, we did have to add some additional references in here to light up those Windows 10 APIs. So in here, you can see we've added those in just like that. So I'm going to run this back up. And again, there was a question earlier on around documentation. The specific assemblies that you need to go add for the documentation for Windows 10 APIs, they are all online and documented, so I've not spent a lot of time on this here. Again, we're going to push the code out on GitHub afterwards, so you'll be able to play this and see it all working for real. So actually, that was the UWP app, but let's try and do something a little bit more clever in here. I'm going to go back to the WinForms app and run this back up. And we can assume, we'll see it in a moment, that it works through the UWP app as well. But now we're in the WinForms world, but we're calling those Windows 10 APIs through here as well. And you can see here that there's a Windows Hello dialog that pops up, and it's using my webcam right now. It's recognized me as Chris Barker. You can also see more choices in here, different biometric options. So if I wanted to authenticate through PIN, I could do that as well. But face is fine for now. I'm going to hit OK, and I'm then going to be able to go and click on the new order button in here in my WinForms app. So that's how we can start to bring co-evolution of features into our project. Now, the other feature I wanted to show, which I think is incredibly powerful, is that of around engagement and driving push notifications and toast. So I also have a toast notification service in here. And in here, I've just commented the code out for now, so let's just go and comment that. And all we do in here is we use this toast notification manager to get a toast template. And we're just using a very simple toast text template for now. We just want to push up some text. And then inside of that, it gives us an XML DOM element where we can go find the text element in there. And then we can push our message into the XML DOM. And then we can show through the toast notification manager the toast on the device. We're doing everything locally here, but this could absolutely be driven through push notifications, background service, however you choose and whatever works best for you. So now when I run my UWP app up again, we're going to see the Windows Hello code executing in the UWP environment this time rather than the WinForms app. And then we're going to go through create a new order, and we're going to see that the push notification fires to say a new order has been submitted, and we're just waiting for it to ship. So in here, I'm going to go to my toggle button, hit OK. We're going to hit new order, and we're going to go create a new order in here. And we're going to hit submit order. And in the bottom right-hand corner there, you see a notification pops up. The order's been submitted, and it's pending shipping. So again, in real-world scenarios, that would come up, maybe driven by a push notification. So that would pop up. You'd go into the Action Center here, and it would drive engagement back into your app when the user taps on that notification. So you start to see the engagement aspect of this and the benefits through UWP. So finally, I've talked about co-evolution of both of the apps. But the final feature I want to show here is there's going to be instances where you want to be able to bring those real modern experiences that the Universal Windows Platform lights up into your app. And so there's going to be UWP-specific features that you want to show. And in here, what I want to show you is the ink canvas working. So we have our new order form in here. And right now, we just have a set of text boxes, drop-downs, and so on that you saw. What I'm going to do in here is bring in an ink canvas control. So I just have some layout here with a stack panel and then a text block to give it a title. But really the main line here is the ink canvas control that I'm bringing in. And this means I can then start to ask for a signature in that new order form that I have. And I just need to do some wiring up in here in my code behind. So when I go create the new order form, resizing is not working for me there, but when I go and create the new order view model, I just want to make sure that in my view model I have access to the ink canvas. And then what I do in the view model in here is I have some code down here which shows I'm checking on the ink canvas, checking the ink presenter. Are there any strokes that have been registered on there? And if there are, then that means that someone signed for it and we're good to proceed and not block the order. So let's run this back up. And just while that's running up, I'm just looking at the questions that we have coming in here. So question, any plans for UWP to run on Windows 7? We still need to support this operating system, which is why we are on WPF. There are no plans to support UWP on Windows 7, but we totally understand that scenario, and that's why we're really framing this session on with regards to you can continue development of your WPF app. You should absolutely not neglect users there on those older versions of the platform. What we're trying to bring here is a way to start to enable you to target the users that are on Windows 10 with UWP apps and get the most of the code reuse there for the the WPF app as well. So we're trying to bring the code reuse story together there. So I'm just going to go through this authentication step in here again. I'm going to go create a new order this time, and now you can see that I've got a signature field added at the bottom. So I'm going to go add another customer, select another customer in here, another product. We'll specify a few units for our order. And then I'm going to submit the order. It's going to tell me it's an incomplete order, I can't continue, and that's because I haven't put a signature in there. So I'm going to take my pen, and I'm going to put my signature in here, which actually is not working for me at the moment. The battery may have died on that pen. So I'm going to use my finger, because we have flexibility here to use multiple input modalities. So I use my finger, it could be the mouse, it could be the touchpad, and so I put a signature in there. So I submit that off, and now we also have that order submitted as well, get the notification to drive the engagement back. Okay, so from a demo perspective, that's everything that we wanted to show today. And just to recap on what we have shown there, we took the WinForms app, and this is a fairly standard scenario where you have each of those layers. We wanted to show that this isn't just an app calling straight into a database. You will tend to have it going through a business logic layer, through a data access layer into the SQL Server database. We identified the components that were most likely to be able to, well, the low-hanging fruit was to move across to a .NET Standard library, and we took those across. And that enabled us then to start to target UWP and bring those benefits like a more modern experience, driving additional engagement into the app, the additional benefits around servicing and deployment, and so on and so forth. And we were able to start to light those up. So with that, I just want to finish up with one additional benefit that I kind of touched on at the start, which was installation and servicing. And this is a challenge that we've had again for a number of years now. You guys have probably had this in the WPF world, WinForms world, and Win32 more generally. But how do you deploy your app? How do you get it serviced in a reliable way? And Click Once was definitely one of those technologies that enabled us to start to address some of those challenges. Now, in bundling your app as a UWP app and into an AppX package, you get those same benefits, but more. So when you go and install your app from the web, for example, we start to enable intelligent downloads of your app. So what that means is your users can start to use the app before it's fully installed on the device. You can start to break it out into components. You're also going to get automatic updates. So when you go and open up your app, you're not going to get that dialog that pops up and say you need to pull down the update now and restart. It's going to just happen seamlessly in the background. So when the user comes to it, they're always getting the latest and greatest version of your app. You're also going to get differential updates, which means if you go push out a version of your app which is 200 megabytes and then the following one is 300 megabytes, you're not going to have to go pull down that full 300 megabyte footprint every time. We'll do a block comparison across the two packages, and we'll optimize there and just do a differential download and install of the package, so you get benefits there. And then finally, dependency management. We automatically resolve the dependencies you have on other packages, and we pull those down as part of this as well. So you get many more benefits on this installation and servicing side than you otherwise would. So we'll come to questions in just a moment, but the calls to action that we have here really are, if you're a library developer today, take your existing libraries and code and start to port those to .NET Standard 2.0. Now, as we mentioned previously, we are providing a lot of compatibility through the technology. So I mentioned the 70% of NuGet packages today that target .NET Framework are just going to be supported. We put a compatibility shim in there to enable that. But we do recommend that you try and migrate those libraries over to .NET Standard 2, so you have the broadest audience consuming those libraries. And also your apps, so not just libraries, but your apps. And this was the example we showed today where you may have a UI layer which sits in WPF or WinForms, but you can start to then bring the different layers of your app over to .NET Standard, which means you can grow your app into those new audiences running on Windows 10 and beyond. And so you're absolutely not leaving all of that code behind. You can continue to co-evolve both apps in parallel, but you also start to reach those new benefits. So you can start to modernize and extend your existing app to those new audiences. And then the final point, again, we wanted to call out that all the code that you've seen today, the samples, are available on GitHub. So hit the link at the bottom here, go pull down the app. If you have any problems with that, then feel free to ping us on GitHub or on Twitter. And then I think we'll just wrap up here with a few questions.
Sure. So one question, how do you support all inputs in one in Canvas? The control by default will support pen, touch, mouse, trackpad, whatever. So you just use an in Canvas control and inputs are supported. Another question is, what is the plan or correct way to do sideloading of UWP packages or containers? If you have an enterprise certificate or a certificate that all of your users already have trusted on their machines, just sign your package with that certificate, and it's as simple as double-clicking on the package. So when you double-click on the package, it'll go ahead and install it. I think we're running low on time, but let's see if we can get a couple more in. Will we at any point see UWP applications running on different platforms like OS X, Linux, or iOS without the use of Xamarin? Xamarin is the cross-platform mobile story. UWP is the Windows story. I think you'll see increasing investments in being able to share as many assets between the two as possible. But at the end of the day, they are slightly different platforms. So I don't think you'll ever see UWP native projects running on iOS or Android. How do I know which platform is supported by .NET Standard NuGet package? For example, System Reflection Emit is not supported on the UWP .NET native platform. Almost all of the .NET Standard 2.0 libraries are going to be supported, but you will see some nuances because of the .NET Native compilation that throws a wrench in things. I'll see if we can, behind the scenes, draft up a list that we can publish as documentation for some APIs that won't work. And I think that's a wrap. Thanks, everyone.
Thanks for joining us.